Hi everyone. Welcome and thanks for watching. Today I'm going to build my favorite reverb circuit module. This is based on a really cheap Chinese digital signal processing module that you can get from AliExpress. You have to search for DSP 100 kinds reverberation, and that should get you something that looks like this. I will show it to you right now. Here it is. Here's the board itself. It features a chip that when you buy the chip it comes with 16 programs, and somebody wrote an additional, well, up to 100 different algorithms for this chip. It's amazing. It's really, really great. It's a huge bargain. I love it. It comes with a digital readout to let you know what you're working with, and it comes with a rotary encoder. When you get it when you buy it and it comes in the mail, the digital readout and the rotary encoder will be connected, but I broke them apart so I have more flexibility in the way I mount it into my module. Probably you're not going to break it apart, but it still works. Even if you break it apart, that's okay. Another thing I'm going to do with my module is I'm going to replace the crystal with the PT2399 chip, and I'm ignoring it for the delay. I'm just using it as a clock, and it's a voltage controlled clock. So I've never built one of these that's voltage controlled, but I have built them with clocks that are adjustable, but usually just with a knob. So I'm really excited to mess with the voltage control options. Alright, let's build it. Of course, if you're watching this for the first time, you're probably going to want to order one of these first and then wait a long time for it to come in the mail, and then you can start building it. Also, I'll include the rest of the bill of materials in the description or whatever. So let's make it happen. Okay, here's what this circuit is doing. Your signal is going to come in. I'm actually changing this section. I just have, instead of the potentiometer to adjust the input level of this input buffer, I'm just going to include a 47 kilo ohm resistor to ground, because I forgot to put a spot for a potentiometer on this panel. So I'm going to be building this a little bit different. You're obviously not going to probably build a module faceplate like this one, so you can do whatever you want. So here's where the sound comes in. It gets buffered by this op amp. It goes through this little network of resistors, which is called a reverse fader. The op amps here and here are for the wet and the dry. What goes into this other op amp, this buffer, goes into the Magic Reverb black box circuit, the DSP 100 kinds of reverberation. So if you take this potentiometer and turn it to, you bring the wiper to this side, it's going to be grounding out the signal going along here. It won't get through to here. If you bring the wiper down to the other side of the potentiometer, it's grounding out this section, so this doesn't get any signal. So when you turn the wiper toward the top, you're grounding out the top. That would end up being dry. Put the wiper down to the bottom, that would end up being nothing but wet. Okay, here's the Magic Reverb circuit. It has a stereo out, which is great. It has ping pong delay effects. It has some really good stereo chorus effects. Fantastic. Now, this does weird stuff to the sound. It changes. Of course, this is a 5-volt circuit. The rest of the circuitry in here is plus 12, minus 12. So this reduces the levels going into here. So then what's coming out is also too quiet. So we have these trimmers adjusting the amount of signal that's going to be getting through to this output buffer and volume control. Okay, I'm going to build 2 of this example. I might not build all of that on camera. I'll go ahead and do 1 and then skip forward. Nobody wants to watch the same exact thing twice in a row, even if you build it twice in a row. All right, so this is really a pretty basic, very simple amount of circuitry on the outside of this little magic reverb black box circuit, which I love so much. So yeah, let's get started. All right, the first thing I'm going to do is I'm going to populate the faceplate with all the jacks and all the potentiometers that I might need to put in here. You don't need to watch me do that. So when we come back, this will be populated. I'm going to put the rotary encoder in here. I'm going to put the display in here. In my example, I'm going to use a 3D pen, 3D filament type to stick everything in place. That will keep it nice and secure. But you're on your own, whatever you do. Cool. So, see you in a bit. Okay. So here's the almost completely put together module lid slash front panel. I assume yours is going to look different from this. Have as many input jacks as you need, as many potentiometer things as you need. If you're omitting the clock mod, you won't need some of them. This is what the back looks like. You'll notice I did not include the output buffer and volume control knob, and I'll show you why right now. We'll go ahead and build that as the first thing we're going to build. Here's a 20K potentiometer, and I will need a TL072 chip. Let me grab all my chips so I can root through. I'm actually going to use an NE5532 chip for this. That's another op-amp designed specifically for audio applications. If you want to use a different chip, that's fine. A different op-amp, as long as it's low noise and good for audio. You'll see up here I have a drawing about what the potentiometer legs need to do in this circuit. In this circuit, they need to go like this. First thing you want to do with every chip, you start building with. Okay, if my camera decided not to work, this is what's going on. I'm building this section of the circuit first, right here. The output buffer with volume control. So the first thing you want to do with every new chip you have is put the 100 nanofarad capacitor from the power rail positive and to negative. My favorite helping hand type stuff is poster putty. That's ugly, but it'll work. Alright, there's the capacitor between the rails. Our little diagram right here shows you what to do with any op amp. Wow, look at that. That's what I'm using. Okay, so the NE5532, basically any standard op amp, pins 3 and pins 5 are the non-inverting input, the plus pin. Those two are both going to be grounded. So I run them together like this. And then attach any old random piece of I'm not using this for the resistor, I'm just using it for the piece of metal. Okay. So now both plus inputs are grounded. So this is the negative input right there, and that's the output. So then I go like this. Negative minus output, minus input and output. Let's get it in there like that, let's say. Tricky. There we go. Perfect. Perfect. Bending the other side of the op amp. This is the inverting input, and this is the output over there. Putting the potentiometer legs like this. Now there's a gap there. I'm probably going to need to include a little bit of a lead. I could probably bridge that with some solder, but then as soon as I come in with another wire from somewhere from the out that's going to go to the output jack, it's going to mess with that solder joint, and it's not going to be a good joint anymore. Alright, that looks really good. I'm going to leave a little bit of extra lead right there so that we can use that for the solder the output resistor right here to there. And this, of course, is the ground because it's the two non-inverting inputs of the op-amp. Over here is the inverting input and the output. Those will be cramped to get to, but we'll be able to do it. Alright, so now that is an output buffer and volume control. Now, of course, you can do this, all this stuff with some kind of a prototype board, perf board, vero board, strip board, whatever you want. I'm just showing you that this way works and this way is cheap and I think it's easy. Not everybody's going to think this is easy, but I do. Anyway, give it a try. Think about if you do this with a strip board, you're going to wind up having to run wires to your front panel. And this way, everything's connected directly. Cool. Alright, now I'll go ahead and attach the output resistors, the 330 ohm. These are optional. You could just run wire. Modern op-amps are they're not going to get hurt if they run short-circuited basically forever. However, I'm not sure what would happen if you accidentally plugged in a full low impedance 12 volts in to an output that was trying to put out, for instance, as high or as low volts as it could, so as like negative 12. Negative 12 to positive 12, that's a lot of volts to ask a op-amp pin to kind of deal with. So here's two 220 ohm resistors. They might actually be 200 ohm resistors, I'm not sure, but it's no biggie because this is not critical. You could have anything, you could have 1K, 500 ohm, anything in that sort of range, less than 1 kilo ohm, and down to, of course, 0 ohms. It could be just a wire. Oh dear. I moved it before it cooled. When you do that, sometimes it makes a cold joint. Another thing that designers like to include with their designs is compensating capacitors from the output to the input of the op-amp. I am not smart enough to know why op-amps need that. I've never been. I think older designed op-amps would sometimes self-oscillate, and theoretically new op-amps could also self-oscillate, but it doesn't happen very often anymore. I think it only happens with modern op-amps if there's some kind of really difficult to drive circuit, like I don't even know what that means. Okay, I'm going to put the resistor body right there, so that it's not going to short out against the inverting input. With this circuit, it doesn't really matter which is left and right because it's in mono in and a stereo out. So left and right really is not very critical. For this part of the circuit, mostly what I'm concerned about is what is easiest. You'll notice that my jacks, the RCA jacks, already have solder on them. These RCA jacks are reclaimed from a different project that I didn't use anymore. Alright, I'm making sure that it's not literally touching, because it could theoretically be possible that there could be enough wear on this resistor to actually scrape through the resistor body to something conductive. So anyway, I will do the positive ground and negative rails later. But right now, I'm going to start building the inputs. These are 10K. These are my two input potentiometers. They're going to be the wet and dry faders. The middle pin of both of the potentiometers goes straight to ground. Here's an old 40 conductor hard drive cable from back in the day, when everybody used parallel ATA or SCSI. I guess you could use old SCSI hard drive cables too. In fact, those I think have 60 conductors, so you get even more wires. I am going to take these off for now, just to get them out of my way. Oh, that's much better. Nice and strong. Nice and strong. This is the clock initial, and it goes, the low side of this potentiometer goes straight to ground. So I'll go ahead and do that. I'll run my grounds right now. This potentiometer is another example of a reclaimed part. Nice and strong. Okay, this potentiometer over here is the CV attenuator. I didn't actually draw a CV attenuator on this part of the schematic, but the other one for the other video does have the CP attenuator, and the low side of that one goes to ground as well. It's going to be a little difficult to squeeze a bit of wire into there, so I'll bend this. Alright, so that's pretty tight in there. Well, that's nicely grounded, but then the middle leg of the potentiometer is also being grounded, which is no good. I guess it's time to tweak these just a little bit. I've never broken these legs off of a little potentiometer like this, but of course it is possible, especially if you bend them back and forth and back and forth. But I've only ever bent them a little bit, so try not to be too scared of doing that. Alright, I've got a lot more space now. And that is perfect. Okay. Now, the last place the ground needs to go to, in this part of the circuit at least, is way across here to the output op amp. That looks great. Fantastic. Okay. Now it's time to work on the wet and dry faders. I need a bunch of 10K resistors. Here's a whole bandolier of 10K resistors. Now, 2 of the resistors go straight. Oh, wait. I need a buffer, don't I? Alright, well then let's build this. Okay, I'm actually going to modify the schematic right now. the input, since I don't have the potentiometer here, the attenuator, to basically volume control the input, I'm going to connect the in directly to the input resistors and reverse fader. None of the values are going to change. It'll still be 10K, 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 10K. Alright, so this won't change. I'm just eliminating this buffer. Okay. Sorry, everybody. Alright, so we have two 10K resistors that are going to go straight to from the inputs to the two sides of the potentiometer. Now, of course, everything I do here, I'm going to be duplicating over here. Having a two input, or multiple input, I should say, reverb can be very useful with independent wet and dry. Alright, now I need two more 10K resistors, and these are going to go straight to the legs of the potentiometer as well. Then they're going to go to the buffers. Now we do need buffers here, and they do need to be inverting like this so that the sides of the two of the fader don't interact with each other. I drew up here the little wet and dry pots. The high side, the pair of resistors on the high side get to go well, follow the diagram on the schematic. That looks good. That looks good too. Oops, I'm moving it. Nope. If you move a joint while it's still hot, do it again. Make sure that solder hasn't been moved around right as it's solidifying. Here's something I don't know the answer to. Why is iron a element that gets gradually soft as it heats up, whereas most other elements, as they heat up and approach their melting point, they remain solid, like ice is a perfect example. It's super hard even when it's just 1 degree above its melting point. And of course water is not an element, but most elements are like that. Like aluminum, or I guess this is lead and tin blend of solder. But yeah, I don't know the answer to that question. I think lava probably is the same way, but that's silicon and oxygen. So yeah, it's a mystery. Okay, well I'm going to do the same exact thing over here. Alright, so both of the reverse fader resistor networks are installed. Now we have to run signal wires from the top side and the bottom side. Now as I twist this clockwise, the wiper is going to the wet side, which is this potentiometer, this resistor. So that means this resistor has to be going to the dry side of the circuit. Now, since I eliminated the input buffers right here and here, that means the only op amps I have left are these two. So I can use one more dual op amp. So that's what I'll do. I'll mount it right on top of this op amp so we can keep stuff nice and tidy. Oh, here's my raft of 5532 chips. So very carefully wrapped in a anti-static bag, which who knows how many pairs of fingers stack them like this. I do not know how they do it. I would love to go visit one of those high-rise towers in Hong Kong or in Shenzhen? One of the biggest cities, fastest growing cities. Anyway, okay. So, this op amp is going to stack right on top of this other one. So I'm going to, instead of putting a capacitor there, I'm just going to extend the legs down using a piece of resistor lead. I'm also going to bend all the other pins out besides the power pins. And I'm going to bend the non-inverting input pin over the top. All right. One power capacitor will be good enough for these two chips. Okay. Stuck. Okay, I said I was going to use like some resistor lead, and I really need to do that. I thought I could get away with maybe not doing that, but I need to. double it up, make it a little bit extra strong. Okay. Make sure we have the chip going the same way as the bottom chip. That looks good. Alright. One side. Now, the insulation on these hard drive cables is not by any stretch high temperature. So if you're going to be soldering really close to a wire that's already there, make sure that nothing that gets super hot is touching that insulation, because the insulation will very eagerly just melt through and you'll get unreliable connections or shorts. You don't want shorts unless it's like super warm where you're living, and then shorts are nice, but only as wardrobe, not as part of your electronics projects. There we go. And that little guy is very secure right up there. It's a little flying bug. Alright, we need to ground this. Awesome. Alright, so the buffer going into the Magic Reverb black box circuit has a 4.7K resistor as the gain setting resistor. Down here is a 30K resistor. Alright, here's a 4.7K resistor. I always like to put do what you want, but I like putting the longer end, the more exposed lead, as the output. So if I'm doing it like this, I'll bend it over, and this section right here then is, that represents the output of the amplifier circuit, or whatever kind of circuit you're building. The op amps I'm using here are NE 5532s. They're excellent audio op amps, but they're not particularly good multi-use op amps. So don't try to use them everywhere you see an op amp. The input impedance on these is much lower than it is for some other op amps, like the TL07X series has an input impedance of around 10 megohms. That's like outrageously high. But the impedance of these is like 30K. It's much lower. Okay, here's a 30. This is actually a 27K resistor, because I don't have any 30K. I don't know if 30K is even a standard value. I think 33 is the standard. So I guess I should modify this. 27K. Alright, this is pretty close to the edge of the can, so I'm going to do like this. Of course, these joints that I'm soldering right now are all going to be soldered to again because there's input wires and output wires that need to get soldered to the inputs and outputs. That's okay, because once a component is soldered on both of its ends, or all three, well, 2 points, I guess, just leave it at that. Once a component is soldered on 2 points, then you can undo either, or you can melt either of the sides, and it's no biggie. Alright, so this is the 27K resistor, so the two sides of the faders, this is going to be the dry buffer. So let's see, when I turn this way, that's the wiper going to wet. When I turn it this way, the wiper goes to dry. That means when it's dry, the wet is fully enabled. No, the wet, oh my word, if I turn it to dry, that means the wet is fully grounded. So the wet then, it's going that way, this is wet. Okay, cool. Wet. Let me grab a little bit of wire. When you're working with signals, it's okay to use really little thin wire. I still prefer to use multi-stranded wire. I do have some of this really thin wire that is single strand, and it's just super fragile. It's kind of easy to break. Right, that's not a perfect joint, but it'll do now. Okay, what I'm trying to do is make a little bit of a cut right there in the insulation. Perfect. Wrap it around. Okay. I'm going to redo this joint just a little bit. Hopefully it kind of stays put. Alright, seems good. Alright, so this side goes over to the input. Okay, so here is my potentiometer. I'm turning it all the way wet. When I turn it all the way wet, that means the dry side is grounded. The wet side is as far from ground as it can get. So that means this needs to go to the dry side. The dry side has the 27K resistor, so it goes over here. Whew, that's complicated. If you're working along with me, I hope you're keeping up. I didn't leave myself much wire, so I'm going to have to break out my tweezers. Alright, seems good. This wire that I'm using also has far from high temperature insulation, so keep it away from anything that might ever get hot in the future. And this is the power, so it's definitely going to get soldered too. Alright, so the other side is going to go to the other side. Oh man, there we go. Perfect. I'll go ahead and leave myself a little bit of extra wire on this side so it's not such tight. So yeah, there we go. It's going to go right there. This wire, the insulation creeps away from heat. It doesn't look super great, but it'll work. Alright, now the fun part. Let's mark off some parts. I got the output buffers. I've got all these parts. I've got the dry buffer. I've got the wet buffer. Now it's time to start working on the Magic Reverb black box circuit. This is an L7805. It is a regulator. It takes 12 volts in and puts 5 volts out. We need that for this circuit because this circuit has 5 volts in ground. So all we need for this circuit is a 100 nanofarad capacitor and a 1 microfarad capacitor. I'm going to actually bend the legs to look like the picture. There we go. Here's a 100 nanofarad capacitor. And here's a 1 microfarad capacitor. This middle leg goes to ground. This leg on the left is where the 5 volts comes out. since the middle leg is ground, the minus part of the electrolytic capacitor needs to go there. I just recently learned how they make electrolytic capacitors, and you can make them yourself if you want. I've thought about it because a roll of tinfoil is cheaper than, a giant capacitor. However, it's not likely to happen because the ones I make even would be pretty bulky and fragile, and they would not be very good. Bigger chips like this have a lot of thermal inertia, so sometimes they're pretty tough to solder to if you have a weak piece of crap soldering iron like I do. Oh, this one worked out okay. Maybe it's because my tip is so short right now. Now, of course, it's going to stay really hot for a long time, so don't solder on it and then grab it right away. Okay, it's not too bad. Yep, it's still pretty hot. Plus 5 volts, ground. Plus 5 volts, ground. Ground. And then I'll run a little jumper to plus 5 volts. Since this circuit, this PCB is made in China for mass for sale all over the world, the solder is going to be silver bearing, it's not going to be lead bearing, so it's going to be a lot harder to work with. If you have lead solder, then you're going to get spoiled. Okay. Yeah, I had to add some lead solder in there to make it melt more easily. Cool. Plus 5 volts. Let's see if I can find a random resistor. I have all these scattered resistors that I've lost the value to just kicking around my work area. And I could figure out how to read the stripes even though I can't hardly tell the difference between red and brown because, yeah, it's hard to tell. Okay. I'm going to put some lead solder there. There we go. I'm going to have my doubled up component lead there. Okay, that looks fantastic. I'm going to cut this not perfectly short because I need to grab 5 volts off of there so I can power my clock circuit from it. Yeah, there we go. So then 12 volts will go in right here, and that will provide a nice consistent 5 volts to this circuit. All right, now let's pull out the crystal. This is optional. Don't do this unless you're ready to build, or unless you've already built this other circuit, which I lost. Here it is. This is the PT2399. There is going to be a 5-volt signal coming off this, a clock signal coming off this. It will be adjustable depending on this voltage or the voltage coming into the module right there. So this part is optional. Do not cut this crystal off if you're not going to do this mod. Because if you cut this crystal off and then don't provide a clock to the chip, it just won't run. It won't start up. It'll just sit there hissing, or it won't do anything. I don't know what it'll do. All right. The connection you want to make is to the top, the one that actually says X1 near it. My soldering iron tip is pretty dull right now and super dirty. So before I do this really detailed fiddly soldering, I'm going to scrape the tip off and sharpen it. See, what I'm doing is squeezing. Yeah, that looks really good. Nice and sharp. Goodbye, little crystal. Bye-bye. Precision engineered. Tiny, tiny little thing. Amazing. Alright, now I need to get a little bit of wire into that tiny little bit of space. Okay, it's going to shrink way back. Oh, I have a stray wire. Maybe I'll just try heating the end of this and see if the insulation creeps back. Yep, it worked. Okay, let's see if I can touch with a very gentle nope. I bridged them. Okay, try again. Oh, I think I got it. Cool. I'm going to do a continuity test. To make sure that it is connected where it's supposed to be and that it's not bridged. Yep, that's where it's supposed to be connected. Is it bridged? It is not bridged. Cool. It's touching pin 3, but not pin 4. Or pin 5, 6, 7, or 8. LOL. Alright, cool. So now we have the clock in right here. We have the power in, which I did on the back of the board, not on the front. And now we need to do the clock mod for me. I mean, I'm going to do the clock mod. If you're skipping the clock mod, you don't have to do this part. I'm just taking off. I built this yesterday, and I needed to test it with the power. So I'm taking that off. That's what I'm doing right now. And this is the potentiometer I tested it with. I'm going to remove it from that. It's being so annoying. Okay. Cool. All right. Okay, now in my schematic, I have a 2.2 meg resistor going from the input, the CV input, through this potentiometer, and it's also going to go there. So that's what I'm going to attach right now. .2 megohm resistor, which looks like red, red, black. What is that, green or yellow? It's on a blue background. That's why it's so hard to tell. Okay. Actually, the 2.2 megohm resistor goes to the wiper of the potentiometer that I'm going to use to attenuate. Wow. Okay. I did bend that potentiometer leg again. Some might be getting weak, so I'm kind of flooding it with a little bit of solder to make it stronger. But once it's all put in, it's not like it's going to get any stress. It's not panel mounted, just point to point. Panel, well, it is panel mounted, but it's not also mounted to a PCB. All right. Where's my, there it is. Oh, my ground wire is being all up in my face. Alright. This is the point, the base of the transistor right there, where the 2.2 meg resistor goes. And of course this clock speed CV in is actually going to the wiper of a potentiometer that's between the clock speed CV in and ground. Okay, so this wire goes to the high side of the potentiometer. And then it goes to the input right there. Let's see. Nice and strong. Oh, I remember why I got that wire in the first place. I got it so I could go between the 2.2 meg resistor and the base of the transistor. So now that I remember that's what I was doing, it's what I'll do now. You know what, you guys, I really hope somebody builds this because it is such a great project. This module just blows my mind. Well, the ones I have already installed. And this one, with its CV controllable clock, will blow my mind even more, probably. I wonder what will happen if you basically like try to frequency modulate it with audio rate modulation. I don't know, it's going to be cool. So, let me just do this trick. Cool. To the base of the transistor. Now this resistor that's already here, this 1 meg resistor, is not attached to anything else, so it's going to be all wobbly as soon as I get it hot. So I'll try to work quickly. Try to keep my thumb on it. Oh! I went crazy. Whew. Now that is super janky. Seems strong though. Alright. Nope, not strong. Yep, that's good. So this goes, the 1 meg resistor goes to the wiper of the potentiometer. And the other leg actually goes to 12 volts through a 470K resistor. Now, I do have a small regulator right there. That's a 78L05. L stands for, I think, low, like low power. It's not powerful enough to run the little module, so we can't use that to power the whole module. The whole module? That was only powering the clock when I was testing it. So I'm going to take it off right now. Goodbye, 78L05. I'll use you again later. Right now, this clock speed mods thing is kind of hanging by one resistor and one tiny little wire. I need it to be more solidly mounted. So this really tough piece of ground right here, I'm going to put to the potentiometer right there. And that way it'll be much more secure. Yeah, much better. I want to keep the resistors, metal parts away from each other. Cool. All right. Okay, clock speed mod installed. Let's mark off. Oh my word, I'm so sleepy. All right, I'm just going to mark off. Yep. Got this whole section done. Sweet. All right. Now it's time to try to figure out how we're going to get this put in here. Okay. Here is the wire. For the inputs and outputs. Audio input and output. Okay. Now the color scheme is pretty hilariously bad. So you know what? I'm actually going to reject that completely. I'm going to use some of my rainbow wire. Because that way it'll be my own color scheme, whatever the heck I want. Okay. Here is going to be the input for this module, because that is the 4.7K resistor right there. So let's go with the in. I'm going to go ahead and get these tinned with lead solder. Oh, there's two grounds here. I suppose that's for when you put, you know, audio, like the ins and outs, both expect a ground. I'm going to check the continuity of all the ground planes in here. So the screw holes are not grounded, but both grounds are. I think. Yeah, of course they are. Oh, cool. So input. Why not gray? Oops. Input. Right out and left out. Oh, so sad. Left out. Okay. Cool. Oh, hold on a second. Of course, I'm still using a color scheme that doesn't make any sense, because I have gray, black, and brown, and all three of those colors are, well, doesn't matter. Cool. Now I need to run a nice solid ground. I wonder what kind of wire comes with this kit. Oh, it's about the same. Cool. I'll use the kit supplied wire to ground the module, the little circuit, to the rest of the module. It's kind of confusing to know what to call this because this is a module, but I'm installing it into a module that I'm building. And of course this module has a CV input that will modulate the module in the module. Not simple. Cool. Alright, now I guess the easiest way to get this mounted and secure is to actually use these big old ribbon cables. So I will go ahead and reattach these. Cool. Oh, and then I'm going to curl it up as tightly as I can. How about like that? Okay. I have a lot of panel. My RCA jacks have a little tab. I could run some steel wire from there up to there. Maybe do it in another spot somewhere. Yeah, I think that's what I'll do. And this is the positive of the PT2399, which I'll just jump from the 5 volts there to there because this is the 5 volt regulator. I have some steel wire right here. Galvanized steel wire from the dollar store is actually solderable. It's not always pretty, and it's kind of dirty, so it messes with your iron eventually. But you can use it as part of a well-balanced circuit. if you want. Okay, I'm going to do the same thing with that one right there, up to there. When you're cutting steel like this, don't use your fancy flush cutters because these are, you want to keep the edge. Use some lineman pliers, like diagonal cutters like that. Lineman pliers. Line man. Stick man pliers. I'm going to go ahead and solder to the tab. It's too bad these screw holes aren't grounded, because that'd be a nice convenient way to get a good solid ground into the circuit, but no biggie. Gotta be strong physically. Cool. Alright, I think I'm happy with that. Alright, now my this wire is the crystal. It needs to go down here to pin number 5 of the PT2399. Alright, I'm going to connect the 5 volt. Oh wait, first I'm going to do the crystal, that's what I was doing. Come on. There we go. There's the crystal replacement wire right there. Here's the plus 5 volts. Nope. Yep. Right there. Bam. Fantastic. All right. I'm going to ground this right there. No, I don't think I will, because this is a ground coming off of a power section of the circuit. So grounding it right to the leg of an op amp, especially one that's doing the output or the input, isn't a good idea. Instead, I will ground it to somewhere else on the chassis. I'll just do it down here. I feel like I can see this just fine, but I don't think you can on the camera. So I'm just grounding to a convenient spot on the front panel, which happens to be where the one of the standoff pieces of wires is also attached. It's also soldered. I could have soldered it right there. Alright, so now I need to take these out, left out and right out. I will put them, oh, this is bent, it's not supposed to be bent like that. Okay, this needs to go here. No, it needs to go here and way under there. Oh my word, that's going to be so hard to get to. Oh boy. Alright, well maybe you should watch this all the way through first once, so you can learn from my mistakes. Hiding a important connector that you know you're going to need to get to later, way underneath a bunch of stuff. Maybe that's something to avoid. Alright, well, let's see what I can do. Get a piece of resistor lead nice and tinned. Get your module in a place where, okay, I'm going to undo this right here. Get it out of the way. Okay. Okay, that's going to do it. Oh no. Barely long enough. Another mistake I made that you can learn from. Don't cut everything without measuring. Okay. That will do that, and this will do this. That's awfully close. In fact, I think it's literally touching the negative rail, which would probably at least surprise stuff, maybe even blow stuff up. So I'm stretching it or moving it far away from there. Cool, now it's time to attach that output resistor again to the output. Okay, this will work. There we go. Make sure nothing is touching anything. That's a pretty scary spot right there. But as long as nothing's touching anything that shouldn't be touching, it'll be alright. Okay, now we have the input going here. We have the output of the dry. Okay, the output of the dry. Oh no. I need trimmers. I forgot about the trimmers. Okay, cool. We'll put the trimmers up here. Yeah, I'll put the trimmers right up here. Okay, here's two 10K trimmers. We're going to use these to adjust the gain of the output buffer, or of this section of the output buffer. Uh-oh, I've got some bridging. Alright, I fixed it. Alright. So, with this trimmer, higher impedance is going to be quieter, lower impedance is going to be louder, and it seems like turning it clockwise should make it louder, which pulls the wiper closer to this leg. So it's going to go like this. These two are going to connect to one part of the circuit, that'll connect to the other. And it doesn't matter, it's not polarized, so you can put it either way. But I'm going to use the two legs, since they're stronger, and attach the two legs right here. And then do the same thing with the other one. Alright. Vander Arc B. Alright, cool. left out. That's what LO stands for, I assume. RO stands for right out. These modules might not all be identical. So having the ability to trim the wet signal to be louder or quieter seems to make a lot of sense to me. One of the modules that I built, the wet signal is much hotter than the dry, which kind of turns out okay. But but the other module I built like this does have much more balanced levels between wet and dry. So being able to tweak those values is important. Alright, I also need two. Alright, so this 10K trimmer I got in there. Check, check. I need two 10K resistors going from the dry buffer into the output buffers on the far end of the trimmer, so right here. Now, if you're an electrical, like an audio engineer, you will see that you'll notice that this part of the circuit is all running at basically virtual ground because of the way these mixers work, these buffers, these amps work, inverting amp. That's kind of a no-no to leave that long of wire. I feel kind of bad. If you design this, oh my goodness, because yeah, this should be shorter because it's basically sitting there as a zero or as a virtual ground, basically an antenna. It might pick up noise, especially since this is a digital circuit. I'm just going to leave it. We'll see how it sounds, if you can tell, when it's all put together. Alright, I'm just making sure. I'm getting distracted. Making sure the power isn't touching the ground. Alright. This input is going from the wet buffer, which is right there. So that needs to go right to there. I feel like this project is pretty hard to follow along on. I hope it's not too hard. I hope somebody builds it. Okay. Yep, there we go. Alright, so this output right here is the dry output. I need two 10K resistors. I will go ahead and attach those right there. These 10K resistors. Keeping the virtual ground from this area of the circuit as short as I can. In my actual synthesizer, all of the first mixer that I built, I thought it was just amazing that the way these inverting mixers work, these inverting inverting amplifiers where there's a virtual ground. I thought it was just so cool that you could basically daisy chain a wire from input resistor to input resistor to input resistor. And so I end up having like it's literally almost a foot long of wire in the back of my synthesizer at 0 voltage at virtual ground. That's bad. Shouldn't do that. Let's see if this works. Oh, look at that, it worked. Cool. And then I'm going to attach it to right here. You know what? Nope, that's not going to work. It's too crowded. I guess I'll attach it up here. Cool. Let's make sure this is still secure. Yep. And what this is it's from the output of the dry side right there. Is this going to be long enough? Oh, that random piece of wire is the perfect length. All right. I made an error. This side is actually the wet side, and the other side over here is actually the dry side. So, yeah, if you're following along, you have just got to be so annoyed with me right now. So switch those back. I mean, yeah. Just follow the schematic as carefully as you can. And I mean, this will still work, but I think I'm just sleep deprived, maybe. Okay, that seems good. Alright. I'm going to run this ground to this right here. Make sure stuff's all grounded like it should be. Now I got to run the positive and the negative voltage right there and there. First I'm going to kind of clean up this area, make sure nothing is touching the wires the areas that I'm going to be soldering to. Okay, that seems okay. Get some power lead. Okay, here's some power lead. In my synthesizer, orange, or like copper color or brown, that family of color is always positive. In your synthesizer, you can obviously have your own standard, your own convention, but this works for me. Actually, brown is going to be ground. Green is always negative, and either white or brown is always ground. Green is negative. So negative. Alright, that's going to work right there. Beautiful. I also need the plus 12 to come right up here to give power to the 5-volt regulator. Alright, the power should be all good. Now I need to get, I guess this is a good ground wire. It's kind of thin, actually. I'll just put another piece of ground right there. Cool. I'll give it a once over. Look at the schematic. Okay. Got these trimmers. Yep. Got the two 10K resistors. Yep. Got the wire going from there down to the one with a 27K resistor. Oh my word, I was right the first time. Let me just triple, quadruple check. When I turn this way, that takes the ground to this side. This is wet, so that means this needs to be dry. Yep, I was right the first time. Man, you guys, if I even release this, okay, I'm feeling very fuzzy and not very smart right now, so I'm not sure if I have the wet and dry wires the right way, the way they're supposed to be. Okay, let's think about it. This side needs to go into the reverb module. That means this is wet, which means when I turn it like this, it needs to be, oh yeah, okay, cool. So if you switched it, because I was confused and said switch it, I was actually confused when I thought I was confused. I was not. Alright, so we got the 10K resistors, we got the buffers, we got the crossfaders, we have the magic reverb box, we have the clock replacer, we have the wet, well, everything. Okay, it's time to plug it in. Oh, see if it works. It's going to be a hassle to get a sound source into it because I don't really have a convenient way to get sound. I guess I could pull my synthesizer out. Negative to what? Why is that not tinned? Negative to negative. Positive to positive. Oh, that's not tinned either. And then ground to ground. Sweet. Just checking visually, make sure everything's not touching the way it's supposed to not be touching. Alright, that looks good, that looks good. That looks good, that looks good. That looks good. Alright, so here's my power. And I will plug in the little thing. Alright, let's just use this one. Cool. I'm just moving the power wires away from each other so they don't short out. I'm moving random wires off of my desk area. Okay, let's see if it powers up without smoking. Alright, no smoke. Let's check the input so I don't blow up my phone. It says 0 volts, which is what I want to see. So now, oh, I don't have the output plugged in. Here's my phone. Let's play some of my music. There's a lot of noise. And my phone is communicating to the towers. Come on. Oh, I forgot to wire this little dude to plus 12 volts. So for some reason the PT2399 clock is not working very well. Is this going to do it? Yep, that'll do it. Soldering over my phone, that probably is not the best idea ever. you can go to any old plus. So I'll put it right there on that op amp. Pin number 8. Cool. Now let's try it again. Yep. Oh, well, there's delay in there already. Yeah, there you go, guys. With some of the effects, like 63, I think is some kind of a phaser. And of course, we're only listening to one channel right now, plus this microphone is only mono. So, some of them aren't going to respond very well to modulation, but some of the ones like the delays. Oh, this is a phaser. That sounds great. This is pitch delay. Here's dry. Bring in some wet. Okay, I'll call that a success. Thanks for watching. Let me try a different, let's do something else. Let's listen to some Jessica Kurt. Okay, this is just techno. Well, it's techno. Bring in some wet. Dry. Jeremy Ensley. A podcast. Who really attacked Saudi Arabia? The Daily.
From the New York Times.
Okay, the Daily's funny because they do a lot of reverb effects, like to bring drama to certain things. So let's try adding reverb to the Daily.
For the weekend attacks on Saudi Arabia's facilities, Dean said unclear things are likely to go wrong. It's Tuesday, September 17th. David, describe the scene in Saudi Arabia on Saturday.
Well, Michael, we're all still trying to piece it together, but what we do know is that it's about 3:30 in the morning of Saturday morning in Saudi Arabia.
Yep.
There were a series of explosions at a number of refineries. And of course it was, dark. No one exactly knew what was happening. The fires were burning. It wasn't clear where they came from. And it wasn't until the sun rose that they saw a really
All right, I'll call that a great, great success.
And what they
Cool.
discovered was that a number of their